Hello, nice to see you again. I'm Chris. In this video, I'll use the 2D barcode, 2D barcode reader from Keyence SR750, and then to use is Ethernet IP adapter functions, and then to connect to my TwinCAT Ethernet IP scanner with DF6281. I hope you will like my video, and let's start. But before we start, maybe you ask some questions. Why you will start this tutorial? Because I think in last year I received this comment. Do you have any videos related to Keyence SR5000, 2000, 1000 or 750 with Beckhoff? So at that time, don't worry, I always remember your comment and take in my mind. Then I will feedback you in some time. Let's start. Okay, before we jump to the video, let me introduce myself again. I'm Chris and I'm coming from Hong Kong. Now I'm working with some factory automation stuff, and I also have Twitter and YouTube and blog. If you like me and you have some communicate with me, just please follow this stuff. Thank you. Okay, so here is just a screenshot that I take from the operation manual that show you what is the basic operations for the startup when you use SR750. First of all, you need to open the box, right? Then you need to install the Auto ID network navigator into your setup PC. Then you're connecting to your SR7500 with Ethernet cable. And after you set it up, then you can control the SR7500 with your PC over PLC with Ethernet RS232C or any I/O terminal. And here is also a flow to show you that how to use it, how to set up. Then you need to check your package, then you need to connect the cable, and then you use the software to configure and send the setting, and then you install the SR7500 series to the position, to the position that you should install it, and then finally you can adjust it. So here is a screenshot of the software. This is Auto ID network navigators, and you can see here read the barcode and the data matrix or code 39. So many types of stuff. I'm not introducing here. Then you can reference the manual to see what kind of data that they can read. And for the Keyence SR7500, they not only support Ethernet IP, they also support Ethernet and circuit communications and RS234. They also have FTP server to allow you to send, but they have FTP functions to allow you to send data to any FTP servers. And in this tutorial, I'll use Ethernet IP, but I'll make one more tutorial to use Ethernet. So here is a screen that the pictures that show you how Ethernet IP with SR7500s work inside. Then by using Ethernet IP, you can read the instructions. You can do the preset instruction or calibration, handling, etc., blah blah blah, and all the data will update in a fixed communication cycle that is set in your PLC. So here is the instant for the input data and output data. Then this I also just screenshot from I just cut from the manual. Then if you want to get more information, please reference the manual to get the meaning of each bit. Yeah, and I think I'm not explaining too much in here. Okay, finally here's the time chart that I'll use in this time. That I will send a request then to the barcode reader, the code reader, and they will feedback me a 0 to the try busy, and then after that they depends on the result to send me a repeat, a complete, or an error. And to error, then you have the error code or something. Okay, I think my explanation is enough. Now I can shift to my to my camera. Then I can show you what is the real hardware I'm using this time. Let's start. Okay, now I turn on my camera, and here you see I connecting to my Keyence SR7500, and here's the power cable and the level cable. Always connect to my hub that is connected to my TwinCAT PLC, and because this time I'm using a normal small PC that with TwinCAT runtime inside, so maybe you cannot see that might have any TwinCAT IP Beckhoff IBC this time, but the theory is same. Okay, and in here you can see I have two types of I think to have 2D code. The first one is QR code, and this one is data matrix. Then I can use this one to an auto ID navigator to read this code from their Keyence software first. Okay, so I open my software, and for the first of all, you need to go to plus bottom, and then choose which interface that you're using. I'm using Ethernet, and then you can also search or manually add. And for the IP default is 192.168.100.100. Then after, please register your device to your project. Okay, so and then now I will press the monitor button. Then the camera will be turned on, and you see the image change. There is a live image view in here. Okay, so and just a second. Great. Now you see there's a live picture view here. Then I will make my camera a little bit close to the QR code and data matrix. And sorry, because I didn't fix my camera, so I just can use my hand. Okay, just wait a second. Okay, great. You see now I can read the QR code and the data matrix also. And here you see the reading test 100%, and you can see the data that I'm reading from here. So it seems like the function that my camera is working, and my QR code is great, no problem. Then finally, you need to go to some setting to configure that, to make sure that you enable the Ethernet IP setting. For example, you go to Communication 1 tab and to set the IP address to match your applications, and to go to Communication 2 tab to make sure that you are using Ethernet IP in here. And for correct details bottom, then you can change the input assembly and output assembly, but I think no need to change here, just leave in default. And then depends on PLC that you're using, may need to do the byte wrapping. And because in this I'm using Beckhoff TwinCAT3 runtime, so usually you don't need to do the byte wrapping. But if you're using Keyence or Omnon, please click to the enable functions. And then after that, what you do is just go to transfer and send conversions to send the conversions from your project to the camera. And don't forget, if you think it's okay, then press the tuning button to optimize your parameters. Okay, so I think for my introduction here is enough. Now we can switch to TwinCAT3 to make our program. Okay, now we open TwinCAT, then we can start to make the conversions to make the connections to our SR750 Keyence reader. So go to Open IO, device right click, add new items, and then select Ethernet IP scanner, and press none here. So first thing you need to select the target you're connecting to. Go to System, choose Target, and open it. I'm connecting to this TwinCAT runtime, but okay. Here just press No, and then just a second, you need to load some data, I think. Okay, then we can go to adapter, then search, and I think let me think. I think using this one. Yes, I'm using this adapter. Please choose exactly the Ethernet connector, the Ethernet adapter interface that you are using in your applications. And then we go to Synchronize Task to create a task for our Ethernet IP scanner. And then to select your cycle clicks. And finally, to go to setting tabs is a very important step that so many people are always forget. And just a second, I don't know why he's freeze. Okay, and go to F800. I think if I didn't make the wrong, is go to IP address. So set up the IP address of your Ethernet IP scanner. Here I will use 101 just for case, and then great, I will choose the I don't know why it didn't. Okay, let me end again. Okay, and oh sorry, yes, default gateway. Okay, I need to in the 0 here at 225.5.255.255.250, and it should work. Just a second. Okay, after setting the IP, that what you need to do is you need to install EDS file. So go to Keyence website and search SR750 and then download the EDS file and then install in these locations. Okay, here is C TwinCAT 3.1 config IO Ethernet IP, and then after you install EDS file, then we can add the SR750 in our project. Select this Ethernet IP scanner, right click, add new items, and then go to Keyence, and then you can find SR750 if you install this device in your PC. Click it. Okay, now a SR750 is installed in your project, and then you need to go to setting to set up the IP address of your device. In this case, it will be 192.168.100.100. Okay, save it. But this is not enough. You need to right click and add our connections. In here, I use class 1. It should be exclusive owner. And TwinCAT will ask you that is you want to create the variables that is reference to your ETS file. Sure, yes. And a new connections is added in your project, and in the project you will find inputs and output. All the data is referenced is same as that the screenshot I showed you in the slide before. Okay, now we can add the PLC. Go to right click, add new items, PLC template, standard PLC. You need some times. Okay, a PLC is add. Now first of all, I to download the project to our TwinCAT runtime. Plus activate conversions and okay. This end the license if you end the missing license if you have. Reset our TwinCAT in run mode. Okay, and then now we can log in. Yes. Play it. Okay, so now we can, the first step, we can go to the box one. There's the input. Okay, I think now I don't have IP address in here. Just a bit strange. And go to input status and online. Now it should be seen as 0. It means that the connection is okay. You don't have any error. And if you can see the hub that you are connecting to your device, then you see the flashing is very fast because it depends on your RPS settings. And actually, you can set your RPS settings in here. I think here I set it as 20 milliseconds. Yeah, good. That's enough. Okay, so just log out, and then now we can start to add the PLC program. For the first one, I would like to add some DUTs, the user data types. Go to DUTS files, right click add a DUT, and then here I will give a name called SR750 EIP in data, and press open. Okay, now I prepare the data that on my notepad, so I directly copy and then paste to here. and all this data is same as the screenshot that I show in the slide that you need to, maybe you can reference the manual. But don't worry, I will also upload my project to Beckhoff, and then post the link in the end of the description of my videos. Then you can download it to see actually what is it mapping to. Then we can right click duty. This time right at the output data SR750 and EIP out data. Right. Okay. That's. I also same. I prepared data, so I just paste from my notepad and copy my notepad, and I have to paste to here. And then finally, I would like to create one more data types to group these two data types, and I call it EIP. And then I'll have a in data at %I star mark is equal to DUT SR750 and in data, and I'll have a out at %Q star mark at DUT SR750 and EIP out data. Great. And then finally, I would like to add one more variables. It's called common status to make sure that the connections is an IP connections between my TwinCAT and SR750 is connecting without any problems. It should be a UID type. Great. And then we can build it. No error. Then we can map the data one by one. So go to status inside our SR750, right click, and then change. Oh, sorry, I need to add a GVL first. I'll go GVL mapping, and it should be a SR750 1 DUT SR700 EIP. Then I build my solution again. Then go to status. Yes, I can see status variables in here. Then I can plus the input. Then I can just go to change links, and then do error read, and just click it all by one. Then you can also try to map all these by runtime, but here I just show you to a simple way, the manual way to edit by one, and then read complete, and then if I press complete, register and tune complete. Then here they will also have a request and with filter, preset filter. This I think there's some fault, and here you have also the input status, and here is to have the output status. Okay, and then you have a stable, I think from here to here, right? You have a stable, you have a matching ISO data, IAM, and then you have some word data, for example, the matching level, ISO, and AM. And here you have a read result code, preset result code, register result code, and tuning result code. And here you have some general error code. And finally, you here just right click here, do the same thing. And here's the data size. I think it's a change link, and then just copy all this result data and right click and change multiple links and directly choose the array. Okay, then do the same thing for the output. Then you see this one, right? Result data, you have a error clear from here to here. Okay, error clear. Okay, just click it and make sure to request. Okay, and then here do the same things. Okay, and here's so right. So here's a bank number, and then you have a user data type size, and yes is your user data type. You just select all and right click, change multiple links, and then choose this one. Great. Okay, now we can start to create our program. Okay, I assume this one to be big. Okay, so first one, I would like to define result. It should be a string, okay, and a b read is be bool. Then I would like to have a R tracker to detect a pulse up signal, and I have a b reset, and I have a b clear. Great. And I should it back. Okay, so for example, I would like to GVL underscore mapping dot SR701 dot O dot read request is equal to root is equal to b read, and not GVL mapping dot SR701 and dot com status dot 0. It means that there's no communication error between my Ethernet IP scanner and the SR750. Okay, so and then I would like to detect the read request signal. CLK is equal to, I would like to just copy this one. Great. Okay, then if R dot Q, then what you want to do, you need to reset my result is equal to a empty string. After that, you may need to have GVL mapping dot SR701 dot in dot read complete. If it's complete, then we can move the data. MOV. Great. For the destination, it should be the address of the result. And for SRC source, it should be GVL mapping dot in dot SR701 dot in dot result data. I think it's result data, right? And how many data so you need to move? It should be mapping SR1 dot in dot result data size. Great. But else if, okay, GVL mapping dot SR751 dot in dot read filter, then result is equal to error. Okay, so something like this. But you can make the retry or something, but I will not make too much in here. And then finally, you can just mapping dot SR701 dot O dot error clear is equal to b reset, and GVL mapping dot SR701 dot O dot complete, I think complete, right? Dot read complete reset. Complete reset is equal to be clear. Great, done. Okay, the program is very clear. I'm just send the output request, depends on my bit and the connect and the communications, and I reset the buffer, and if the read operation is okay, then I will move the result to my buffer. Even I will move this error. Okay, now we can down my project. Great. Okay, great. Good. Let's see the here. Okay, 0 is connecting, so no need to check too much in here. And now we can turn our camera again to see what happened, what's going on with our program. Okay, now we turn our camera, and the right hand side is our TwinCAT project side, and in the left hand side is our Auto ID network navigators. So what I'm doing now is I would like to turn on my B read bit to see what happened. Great, you see in the there's a green rectangle is marking out our QR code, and you see the read the data is ABCDEFG something. And but now even if I turn off the B read bit, it will not turn off the read complete flag. We need to press the B clear. Great, now we see the B clear is read complete is turned off. Then now we can set to read a new result. Okay, then now I would like to try to read the other data matrix code in to see what happened. Just a second. Okay, as you see, although now in the second one I try to read the data matrix, then I can read the data, then it is Keyence something. Okay, I hope you will like my videos, and in the next video I will try to use TwinCAT. And please have a good day. Bye bye.